Okay, so in last session we have seen calculations regarding the PWM. Now we have to implement the code for same. Okay, so let's start with the new project. Here, let's mention the controller STM 32F103C8T6. Click on next here, Servo demo. I'm going to provide the name. Let's finish this. Now we are just going to use timer 3. Okay, the PA6 pin that we have used last time. So there is no much settings in this. Channel 1, PWM generation channel 1. Now here we have to set few things. First is PSC value that we have calculated and its value was 79. ARR value, that is auto reload resistor, was 1999. Okay, PWM mode is enable. Okay, no division. So here you don't have to do the division. Okay, so there is option for division by 2, division by 4, but we don't need it right now. After that, we have the clock configuration. So we are going to use HSI normal clock 8 megahertz, and we are going to get 8 megahertz over here. Yes, here peripheral clocks and timer clocks. So for timer, we are getting the 8 megahertz. So there is no need to change anything over here. Let's save this and generate the output code. So what we should look for first, that the prescaler value has been set properly or not. So yes, prescaler is 79 and your auto reload resistor, that is period actually, so it is 1999. So that part is done. Now what we have to do, we are going to declare two important macros. Okay, so what is macro? It is a constant value. Okay, so hash define servo underscore minimum value, that is 50. Define servo underscore max, it is 250. Now whenever we are writing this servo min or servo max, that value will be, that name will be replaced by these values. Okay, so it is just our time period, that zero point 0.5 microseconds, sorry, zero point 0.5 milliseconds and 2 milliseconds. So but in practical testing I found that it takes 2.5 milliseconds actually instead of 20 milliseconds, 25 milliseconds. Okay, so here 79 199. Okay, so here just what we have changed, this part, instead of 2 millisecond it takes I think 2.5. Let me check it. Okay, according to the description it takes 2 millisecond, but in practical testing I found that it takes 2.5, around 2.5 milliseconds. Okay, otherwise it is going to rotate up to 90-degree only. You can try that. Now what we have to do in coding later on, so our servo min max values have been fixed. After this we have to write one function. So before int main we are going to write that. So void, so I'm going to write it in the style of Arduino controllers code. So servo write servo servo write. Here we are going to just pass the angle. Okay, so unsigned integer 8 underscore t. So angle will be between 0 to 180 only. So we are taking the u and 8. So here angle will be there. After this we have to define the pulse. Okay, so pulse is going to change according to our need. Okay, so p pulse is equal to servo, so we're having servo min plus what we have to do, we have to calculate the difference between two timings. That is, first one is again servo max minus servo min. Okay, it is time period between the zero point 0.5 and 2 milliseconds. Okay, that we have seen earlier during the description, into the angle we want to rotate the shaft at, divided by 180 degree. We are just, what we are going to do, we are doing right now, we are just dividing the intermediate time period, that is for 0 degree and 1 degree, into 180 degrees. Okay, so we can rotate the shaft with the accuracy of nearly 1 degree. Okay, and after this we are going to pass this value, we need to pass this value to the built-in HL timer function, timer underscore set and compare. Okay, so here we have to mention the handler htm3 comma timer channel underscore one, and we are going to pass the pulse. So this part is done. Here we have to, instead of okay, done. Now we have to call this function into our main code. Now in this case, what we have to do first, we have to start the PWM. So HL underscore timer underscore PWM underscore start. Okay, it is taking the handler by itself. After that, the channel is timer underscore channel one is there. Okay, so this part is done. Now we are going to design one for loop where we are going to start from 0 up to 180. So motor will rotate slowly from 0 to 180 degree. So for uint 8 underscore t, angle will start from 0 initially. Angle is less than equal to 180 comma angle plus plus. Okay, now here we are going to just call our function. So right, I'm going to pass the angle. Here we have to introduce one delay. Now to you have to keep in mind that this delay should be of specific value only. Just a second. Tail underscore delay. So it should be of 20 millisecond only. If you add more delay, your motor is going to feel sluggish. If you reduce this delay, it is going to make sudden jerks in the movement. Okay, so to avoid that, for smooth functioning, you have to add 20 milliseconds of delay, because after 20 milliseconds only, your servo motor is going to expect or read the next value. Okay, so for in this function, it is going from 0 to 180. We are going to copy paste it as it is, and here what we are going to do, we are going to make it from 180 to 0. It is not mandatory to write uint. You can write simple int also. I'll write simple int here, so you will not get any doubts. So here initially we are going to keep it at 180. Angle should be greater than equal to 0, angle minus minus. This part is done. The delay will remain same. So let's build it. So build it here. Let's check the prescaler and auto reload resistor values. Okay, they are set properly. After this, let's right click over here. So we are having the hex file or not. Let's see that. So here for generating hex file, post build outputs, you have to check these apply and close. Okay, let's rebuild it again. So we are having our hex. So in next practical, what we are going to do simply, we are going to upload this code on the hardware and we are going to see actual working of the motor. We have already seen the increment and decrement in the pulse width of PWM. Okay, so we are not going to see that again in the protest. We are going to directly upload this code on hardware in next session.